Okay, we still know what the monotone convergence theorem is? Was in our notes? We ended on it last time.
If an increasing sequence has an upper bound, then it converges.
What is it, Sam? I see you have it in front of you.
Monotone sequence of real numbers is convergent if and only if it is bounded.
Let's go.
Set.
Mm-hmm.
And then if x equals x and is a bounded increasing sequence, then the limit is the supremum, and then if it's decreasing, then the limit is the minimum.
Okay, so we're going to go ahead and prove the monotone convergence theorem. So, we're going to go one way. So, we're going to assume we have a convergent sequence. So, let xn, n equal 1 to infinity, be a convergent sequence. Do we have something in our knowledge bank that we can use here? Maybe a previous theorem. Okay, do we know the theorem number?
3 point something.
3.2.2. So by 3.2.2, our sequence is bounded. Now, don't you wish all proofs were that short? Let's go the other direction. Okay. So we're going to suppose what?
Suppose it's bounded.
So we're going to suppose our sequence is bounded. And I should put in here that it's a monotone sequence. Monotone. Okay, so we have a bounded monotone sequence. Okay, we are trying to show, right, what? Yep. Okay. So, as our sequence is monotone, what do we know?
It either always increases or always decreases.
Yeah, so our sequence is either increasing or decreasing. So we're going to have two cases here. So case one, our sequence is increasing. Okay. So since our sequence is increasing, so we know it's increasing and bounded. What does bounded tell us? What do we know?
There exists some number that the sequence never hits, or like never goes beyond. Bounded can both ends. So.
Right.
So if the case is increasing, there exists some number such that there is no xn that is greater than that bound.
Yeah, so xn is less than m for all n in the naturals. Okay, so right, we're using bounded above here, right? More so than just, but right, bounded means bounded below and above, okay? So we could, in order to make this clearer, right, we can actually go ahead and say, hey, it's bounded above. Right, which tells us the existence of being bigger than xn for all. Okay? Any questions? Okay. That word is useful in the next case, so I'm going to go ahead and throw it out there. Okay. So now let's let A be the set of xn such that n is in the naturals. Okay? So A is a set of all of our terms in our sequence. We know A is not empty, right? And we know A has an upper bound. What does that tell us?
Means it also has a lower bound?
We know it's bound, so it also has a lower bound. But what does this in particular tell us? We have a set that's non-empty, and it has an upper bound. It has a supremum. What's that property called? Completeness property. Our set A has a supremum. Okay. It is also called, which might be the easier name to remember, the supremum property.
Not to say we called it, but we called it.
That should have already been in your notes, so.
You called it.
Okay. So let's let x equal the supremum of our set A. And let's let epsilon be greater than 0. We're going to consider x minus epsilon, which is less than x. Okay, so as x is the supremum of A, right? As our x minus epsilon is less than x, what do we know? So let's look at those equivalent statements to having a supremum.
X minus epsilon is in A?
Not necessarily. Doesn't have to be in A. So it's not an upper bound, okay. What does that mean? There exists an xn in A such that x minus epsilon is less than xn, right? There's something in our set A that's bigger than it. Okay. Now we know this is an increasing sequence. So what does that tell me about everything that's past that n? So what about?
It's greater than xn.
Yeah, so we have 1 minus epsilon, which is less than xn, which is less than or equal to xn for all n greater or equal to capital N. Okay, so now as x is also the sup, we also get the other direction, right? So xn has to be less than or equal to x, right? Which is less than x plus epsilon for every single n in the naturals. So we know x minus epsilon is less than xn, which is less than x plus epsilon, right? For all what? In the naturals? Or do we have a restriction? What do we think? So we didn't have a restriction here for this on the side, but did we have a restriction on this side? So we have to have them greater or equal to that n. Do we have questions on that one? No? We're good? What does that mean? What does that tell us?
Therefore, x of n is the. I was going to say x of n is the sup, but that's true. We already defined it.
Right? Because our n tail definitely converges, right? We have there's some number here, right? For every n that's bigger than that, right? We know it's with an epsilon of our x value. Okay? So it converges to x, which equals our supremum. I'm going to go ahead and say A, since we have it. Okay, questions or concerns?